Equation of a circle, x squared plus y squared equals r squared. That is what it is. Yes. Okay. If I rewrote in terms of y, have y equals square root of r squared minus x squared. Good. That is a curve. Do we agree? Easy question. Yes. Now, starting at that point, I go full circle. I come back here. I want to know the length. Good. From here to that wonderful circle, 360 degrees, too high. What is that length? Yes. Too high.
Well, I'm not gonna lie.
So radius r. Circle's radius r. The radius is r. So not it's just too high. Okay.
2 pi r.
2 pi r. That is the circumference of a circle, 2 pi r. That is the length from here, full circle, back to there. Good? Okay, we know the formula. Let's see if you could use a calculus. If you have to use that functional form to find that answer, it is a definite integral because you're starting at 0, full revolution, get to 2 pi, so 0 to 2 pi. Square root 1 plus dy over dx squared times dx. That is the formula that we just derived. You take infinitesimally small segments, infinitely many segments, in other words. You're adding all those bits, infinitesimally small, integral, so infinitely many tiny lengths, you add them together to get 2 pi r. Good. Well, we have to find the derivative dy over dx. Agreed. What is the derivative of y with respect to x? So if we took the derivative, 3/4 that is inside as x, the derivative of square root of x is 1 over 2 root x. So 2 square root r squared minus x squared. Are we done yet? No, we've got to multiply by the derivative of the inside. 2 times derivative of the radius, which is a constant, 0. Derivative of the inside, I get negative 2x. Yes? The 2 and the negative 2 will get cancelled. I have negative x over square root r squared minus x squared. We've got to take this, plug it in there. So 0 to 2 pi. That is the outer root. The inner term would be 1 plus negative x over square root of r squared minus x squared times dx. Good. From there, u substitution will work. Negative x, if you square it, you'll simply have x squared. Yes. Denominator, root and the square will get cancelled. R squared minus x squared. Not u substitution. A u is involved, but it is not u substitution. 0 to 2 pi. Common denominator again. What is the common denominator that you need to combine 1 plus x squared over r squared minus x squared? R squared minus x squared. Anyway. Good so far. I have a common denominator. So, integral 0 to 2 pi, square root, common denominator, r squared minus x squared, numerator, r squared minus x squared plus x squared dx. Those two will go away. Integral 0 to 2 pi, square root, 1 r squared over r squared minus x squared times dx. Good. 0 to 2 pi. Square root of r squared is simply r. So you take r out. Dx over square root of r squared minus x squared. If you use tricks of and integrate that, plug in the limits, you would end up getting 2 pi r. Good. All that work to get to 2 pi r. Painful. Is it painful or is it not painful? It's definitely painful. Do you see where I'm going with this? So basic distance integral makes it accurate. I'm going with the functional way of rewriting the equation of the circle. I've got to go through that entire process, get to that step, need trig substitution here, and from there I go on to find the length. Very painful. There has to be a better way. Better way is to realize that that is a curve for which a parametric equation is possible. Long time ago, I wrote x and y in terms of theta. I also wrote it in terms of t. Do we remember the parametric equations of a circle? Again, it goes back to the boundaries. I had the rectangular coordinate system here, polar coordinate system there. I made a connection to a point here, to a point there.
It's just the r cosine theta in r sine.
Very good. R cosine t, R sine t. Good. All that pain over there, then leave it behind and go to the formula that we just derived. I still am going to go from 0 to 2 pi. Yes, one full circle. Every one full circle. And now, square root. The formula that we derived is simply dx over dt squared plus dy over dt squared times dt. I said all that pain that we went through, we're going to leave that pain behind. So can I erase? Okay, what is the derivative of x with respect to t? That's easy.
we'll do R sine.
Okay, r sine t and square. Yes, and what about the negative Caitlin? Oh, you did?
Yeah.
Oh. And what about the derivative of r sine t? R cosine t? Is Caitlin like your spokesperson?
What are you talking about?
If that is the case, you've got to pay her a lot of money. She's going wrong the way.
What about everybody else in the class?
Negative r squared. So it becomes r squared sine squared t plus r squared cosine squared t times dt. Do we see a common factor? What is that common factor? R squared. If r squared move out, if you pull r squared out of the root, what would you get? 1. Well, you take that out. R. So r integral 0 to 2 pi square root sine squared t plus cosine squared t dt. But what is that? 1. So that would simply become r integral 0 to 2 pi. Square root of 1 is 1. 1 times dt is dt. What is the integral of dt? T. So r times t evaluated between 0 and 2 pi. Lower limit, it will just be 0. Put in the upper limit, what do you get?
2 pi r.
2 pi r. Isn't that the circumference of the circle? Yes, that is how you find it. Does that make sense? I could have done it the other way. Very painful. Parametric equation makes it simpler. There are ways to find this geometrically also, but I picked a circle because it's simpler case. Any questions? Okay, you tell me, given the choice between this and the other one, which would you go for? Bryce?
It's a 2 pi r. What do you mean? This or the other one? Or the
No,
other?
if you don't know that formula and you're trying to come up with a formula, one approach is to do y equals square root of r squared minus x squared, integrate, come up with the length. Other approach, you have the parametric equations, come up with the length. Which approach would you go for?
From the parametric.
Clearly this one. This one's easy. But there is no such thing, as an easy life, because it was that easy, having a different galaxy. The entire derivation is based on those two equations, correct? Is it possible always to get to those two equations? No. There are cases where you just stop. You cannot come up with points. So, in other words, you're screwed. You have to rely on advanced methods. But in most of the cases, we do have parametric equations. Are we clear? Good. If you have a set of parametric equations for a curve, you can easily find the length using that formula. So either you work hard or you work smart. I like to work smart.